Hello everyone. Today we're going to be designing an industrial wheel commonly used when we see heavy equipment such as scissor lifts. The first thing I like to do when I'm designing is to pick out some sort of reference model that I can go after. Today, because we're doing this industrial wheel for something like a scissor lift, we're gonna kind of pick this industrial looking wheel. Now this is going to be useful through our design process to figure out what features we need to create and how we're going to approach them. So I'm just going to keep that in the background in case that I need to reference it at all. And then I'm going to start with a simple sketch in which I'm going to define the general wheel geometry. For today, I'm going to make a 40 centimeter wheel. Now, I do work in millimeters for most of the time, so if you're following along, I like millimeters. If you want to use a different unit of measurement, I think that's around 15 inches. So feel welcome to test out whatever units you're using. So I'm going to generally need two pieces of geometry to define the external diameter of the wheel. So I'm going to use 400 for the general diameter, and then I'm going to do 325 for the rubber that is going to be the general wheel. And maybe we go a little bit bigger on the rubber and we make it 300 millimeters. And that's going to be the rubber part of the wheel, or the tire as you might want to call it. And I'm going to put those geometries to the side. Then we're also going to need some sort of shaft in the middle. So we need to put some geometry into our wheel that is going to hold the shaft. So I'll make this 100 millimeters. And again, maybe we want to go a bit larger here. We'll do 125. Now inside of this wheel, we're going to need to put a shaft, and that for today is going to be 25 millimeters. So our shaft is going to be 25 millimeters thick. And on top of this, we're also going to want to have some sort of keyhole that is going to allow the shaft to rotate. So we'll make the length of this keyhole 7.5, which is going to give us half of that distance there, and then we'll make it by 5 millimeters. To make things easier for ourselves, we're going to make this construction geometry, and then we're also going to trim a chunk off of our arc there, and that's going to allow us to very easily create that keyhole for the shaft. For anyone that doesn't know, by pressing Q, you can create construction geometry. By pressing M, you can trim the geometry that you're working with. Now, I've already kind of defined a lot of the important geometry that I need. Lastly, we're going to make an arc, and I want this to be a construction arc. So for this arc, we're going to basically just put it in space. We're going to make sure that the inner diameter of the arc is the same as our center point for the circles that we're working with. We can then define what radius we want the arc to have. I'm going to use 100 for today. And then we're going to lastly define the distance between these 2 points. And for today, we're going to use 80. As you can see, that arc is now shifting. So we need to make sure that the center point of the arc is vertical with the center point of our circle. And pretty quickly, I've started creating the right geometry. Another approach to this is, instead of defining the radius of the arc, we might want to approach it by having the distance between these 2 points. So maybe I want 110, so it's a little bit more centered, and that also helps us constrain. You'll notice that anything that is fully blacked out, that's going to be geometry that has been fully defined. Now I'm going to create a slot. You can find the slot in this drop down next to the offset, and I'm going to create a slot for this piece of geometry here, and that's actually not going to be construction. So this slot is just going to be some light weighting that we're going to do on the general piece here. And if we zoom in on it, we should be able to find the slot length, which I think, I don't know where it went. So we're going to try doing this again. Here we go. So instead of 20, let's try for 40. That looks a lot better with the size of my wheel here. We could even go a bit bigger if we wanted to have those holes more pronounced. And once we have that geometry defined, we're just going to OK it. I'm going to hide my planes by pressing P, just so that there's less visual clutter and it's easier to read the dimensions that I'm putting in here if you're following along. Just to go over this keyhole again, I'll just make those dimensions easier to read as well for you if you're following along. Now, the last thing I'm going to want to do is I want to pattern this in a circular pattern so that I can have multiple of these features. So I'm just going to select these here, and that's going to be all the features that I need. Now, this is the amount of features in my pattern. I actually want 5. That's a bit tight, so I'm going to revisit that 50 really quick. And then the last thing I want to do is select the center point for my circular pattern, which I'm going to put right at the center there. Now I can OK that, and you'll see that if I've selected the center point of my pattern, that's going to properly constrain. If that's too large, I'm going to use 45 so that there's a little bit more of a gap. Now that's most of the geometry of the wheel that I'm going to have to define for right now. Making a quick note, I did do this in the front plane. That's going to allow me to use symmetry through my design. The first thing I'm going to do is create an extrusion for a solid. I'm going to make sure that this is a symmetric extrusion, and I'm going to select the rubber part of my wheel. I want this wheel to be around 20 centimeters thick. So that's going to give me a thickness of 20 centimeters through which I'm going to create this wheel. That's the first piece of geometry that I needed to define. Now let's create the interior of the wheel. So I'm going to select this interior piece, which is going to be the main holding piece for the wheel. I'm going to also make this symmetric. Keep in mind that right now, Onshape wants to add that geometry to other pre-existing geometry. I actually want to create a new part because this is going to be the inner hub of the wheel rather than the rubber part. We will later have to assemble those two parts, so I want to make sure that these are independent parts. You'll notice that now Onshape is creating a second part for me. I will make this 10 centimeters or 100 millimeters. I will then extrude the inner diameter, and I will make that 125. And again, I want to be using symmetry. This is where my hub is going to live and where things like my shaft are going to live. So that's going to be a very important piece of geometry as we make this wheel functional. Lastly, we're going to want to create an extrusion for all of these features here because industrial heavy equipment doesn't want to get dirty, or we don't want to be catching dirt in the middle of the wheels. We're just going to create a little indent in there. That's also going to add some aesthetic features to the wheel, which are going to be nice as we finish our design. So again, using symmetry through this the entire way through is going to be very, very handy as we design this. I'm going to hide that sketch as I'm done with it. And I did that by pressing Shift P, which hides my sketch. The next thing I'm going to do is I'm going to rename these parts, right? So I'll actually name the exterior rubber tire, and I'll rename the interior hub. Now I have two parts. This is a core difference in Onshape is that I can design parts in the same environment with no fear of things breaking. So that's starting to look like the wheel that I want. Now I'm going to start putting some trad on my rubber tires so that I can properly have grip on the ground as I'm driving around. To do that, I'm going to sketch in the top sketch, right? So we're going to go on top, and then we're going to create a sketch here. I'm going to use the exterior geometry of the rubber tire that I've already creating by using U for use and Q for construction. Now that I have that exterior line, I can start drafting what I want my my trad to look like. So I'm going to make 3 lines here, nothing super fancy. We just want some basic trad that is going to help us drive around. Now I'm also going to want to put a center point here, which is going to help me drive the center of the trad later. Lastly, I will use a offset, which we can find here, and I'm going to offset those 3 lines. We'll make our trad 20 millimeters thick. I will then also put a center point here, and I will create a line with construction between those 2 center points, in which I will put my last center point. Now, just to show you why I'm doing that, I'll put a center point in one of the 2 construction lines. And then I will select this new center point and the center point I created earlier and I will make these vertical. That has actually created the center of my trad alongside that line. And that's going to be very useful because I want everything centered. Then I'm going to fully constrain the rest of my wheel, and I will use, whoops, that's definitely the wrong number. I will use 60 millimeters on both of my short ends of the wheel to constrain this. Because this is not coinciding right now, I'm just going to make that coinciding, and you can see that that thread's starting to come along. Now there's still some movement in here because it's not fully constrained, so we're also going to want to constrain either the angle or distance of part of that inner geometry. So at 145, you can see what that will look like. Maybe that's a little bit too aggressive, so we'll do a wider angle. So maybe something like 160, right? And maybe that's not aggressive enough. So we'll do 150. That seems like a good middle of the ground, right? So that's most of the geometry. Lastly, I want to close off my trad here with some lines. Make sure that everything is coincident. Here you can see that I was missing the coincident constraint between those lines. And then lastly, I'm going to close it off with the last line. So I am creating simple lines that close off the geometry there so that I can have close geometry in the sketch. So now if I commit that sketch and I hide my parts, you'll see that this is closed off geometry. Because this is construction, when we first created it, it wasn't closed off. Now that I've created those lines in the end, you can see that the geometry has closed itself. We want to do one more thing, which is actually a trick on, well, a trick. It's a great workflow on how to create geometry that takes a part, splits it, and then we can use that split to better control how the part is being cut into. So what I'm going to do is start a sketch on the front plane. Then I'm going to offset this interior geometry here. So by creating an offset of that interior geometry, we'll say I want 15 millimeters. We'll actually say 20 millimeters. And this is going to be where the trad lives. So you're basically deciding how thick do I want my trad to be. And so I'm going to end up on 25. I think that's a good middle point. And we will later be able to use parametrization, which we're putting into this design, to change that trad at any time. So right now I have two sketches, this sketch and this sketch, right? The one for the split and the one for the trad. Now I'm going to extrude that last sketch as a surface, and I'm going to make that a symmetrical surface, and I just want to make sure that it goes through the entire wheel. So we can make that any distance that will go through the entire wheel. For today we'll just use 500 just to make sure that we're cutting into the geometry. Now that we're cutting into the geometry, we can split this part. So I'm going to select the part that I want to split, and I'm going to select the entity I want to split it with. If we don't need to keep the tools, we can unselect this, and this will immediately delete that construction surface that I've just created. And that's just going to be useful because I don't have to deal with it later. Now from here, I'm going to want to extrude cut a solid into that tire, right? So you can see that that's going through the tire. By making the split, I've created a new rubber tire part, and that's going to be how I'm running the split. So now I'm going to remove, I'm going to say through all, and then I'm going to select the merge scope, which is the exterior of my tire. So that's how I'm going to tackle that split. Now from that split, I'm also going to create a circular pattern, and I'm going to pattern a feature. That feature is going to be the extrude, and I'm going to pattern it around the diameter there. By applying per instance, I can now drive that geometry properly and have it patterned. Now from here, what I want to do is select the right number of instances. I'm going to be using 12. And with that, I have the starts of my trad. Now you'll notice I have a lot of parts here. We want to quickly consolidate that, and we're just going to do a Boolean. We're going to select all parts, and we're going to unite them. And now I have the exterior rubber geometry for my tire. That was pretty easy, right? So I have my hub and my tire. Everything's looking pretty good, but I'm quickly going to add some fillets so everything looks a little bit nicer. So we'll select fillet. We can start with 0.5 millimeter just to see what that looks like, and that seems like a reasonable size. So we'll use 0.5 millimeter. If you want a more aggressive fillet, you could go to a full millimeter. It's gonna be fine, right? Either one that you choose, this is going to smooth out your tire a little bit, and it's gonna give it a little bit of a better aesthetic as we kind of start producing it. And in real life, you know, there's no real sharp angles on these tires, so we're gonna want to have that fillet instituted. I'm just quickly going to click through all of the faces that need a fillet. And then we might also want to consider filleting some of the edges of the interior geometry of things like the hub and the general wheel. Now, I don't recommend you do this inner geometry just yet because we're gonna make some more features to it. So if you wanna put a fillet on the hub, great, but stay away from the inner geometry right now, just because we're gonna do some more work with it. So now that we have the general geometry and the general look and feel that we're looking for, we're going to create the method of installation between the rubber tire and the hub itself. To do this, I'm going to once again pull up that sketch that I made earlier. I will hide the parts for clarity, and then I will actually create an extrusion of a surface. And I'm going to select this radius here. Now this is the point of connection between the rubber tire and the hub. And then I'm going to make that symmetric, as we've done with most things in this design. Actually, for this part, we're not gonna make it symmetric because we're gonna mirror the piece, which is gonna be a little bit simpler. So now that that surface is being created, I'm going to select up to face, and I'm going to select this face here. What you notice is that that surface is extending to the face here. I want to do this because I'm going to need to somehow attach my rubber tire to my hub, and this is the way in which we're going to create that geometry through some surfaces and a thickening in just a second. Now that I've created that surface, I'm also going to want to create a ruled surface. So you can look up ruled surface. Whoa. And then we can select this edge here. Now the ruled surface is going to be normal starting off, so that's actually what we're looking for. And you can see that this is how the hub and the rubber tire are going to assemble later down the line. Now 25 millimeters is too aggressive, I would recommend 10. So with 10 millimeters, we've now created a surface geometry that is going to help us attach that rubber component to the hub. To fully finish designing this, what we're going to now do is thicken this component here. So now I'm thickening that surface that I've created, and I'm gonna thicken it into the interior. Instead of 5 millimeters, I will use 3 millimeters, and then we can also thicken this exterior component. And what you'll notice is that that actually creates the fastening component for the hub. Now we're gonna create that as a new part because we do need to mirror it, and then we'll add everything to the hub interior. So now that I've got my general exterior geometry, I can select my mirror. I'm going to be mirroring this part. Now you can select the part itself, but because we've already created it in the front plane, I'm going to just mirror around the front plane. And you'll see that that is actually getting mirrored properly. Last thing I'm going to want to do is create a boolean of those two parts. So I will now select this component and this component, and that is now becoming the wheel hub. And the last component I'll select is that mirror that we created, right? Because we're going to need all of those components together. Now, if you select the hub first, it will actually keep your naming, so you don't have to rename it. If you select one of the other components first, you'll have to rename it, which maybe you don't want to do. So now the interior of our wheel is done, and we can do some more detailing. Now we want to add some details to the shaft and the way that this is being created. So we're gonna do that really quick. So we're gonna start a quick sketch on the top plane. We're going to once again offset this geometry, but because we've added the keyhole, the circle is not gonna be fully flushed out. So maybe a better approach would be to create just a center point in the middle. So we're going to use some construction geometry, create that center point, and then we're going to create a circular piece of geometry, which we're going to use to create some more detailing on the shaft. I will make this 65 centimeters, and then I'm going to create two more circular pieces of geometry that are horizontal with the center point there. So I'll make the exterior of this 20 millimeters and the interior can be 10. From here, we'll finish it off by dimensioning this to be 45 millimeters. And maybe that's a little bit tight. So we'll make this 60 millimeters. And from here, we're going to generate some lines. So we'll put a line here, and we'll put a second line here. I'll clean up the way that the dimensions are being put in place, just in case you're following along. Now, I want to select the lines and the circles that I'm putting together here and make them tangent to one another. So to create tangency, we can press T. So I can select the line, the circle, press T. I can select the line, the circle, press T, and that's adding tangency. So that's already starting to detail my wheel as I want it to be detailed. And from here, we're going to mirror that component. So again, I've been using symmetry through this design, so mirroring can be done across a plane. So you'll notice that the right plane is right at the center of the sketch. I'm just going to select the right plane to mirror across, and then I'm going to select all the features that I just created so I don't have to recreate them. So that quickly gives me that exterior geometry that I was looking for. From here, I can create a quick extrude, and I'm just going to be extrude adding as a solid these faces that we've created, except the circles. Now I'm going to make this 5 millimeters. It does not need to be huge. It's just going to add that component to our shaft. Now, as a last set of steps, I can add some fillets across this geometry here, as well as the interior geometry. And then you can also add some fillets to this interior geometry here. Do remember that you have a backside that you might want to do the same thing with. So from here, we can check all of our fillets. We see that some of these edges actually did not get selected. So let's make sure we select those. And that's given us our tire and wheel. Okay, so this is our finished wheel. And last couple things I would recommend you do is select some appearances so that it looks closer to what you want it to look like. So I'm actually going to select a gray tire, and I'm going to make my hub this off-white color. I would also recommend we assign some materials to this in case we need to do some measurements or we need to do some simulations later. So I'm going to select some rubber, and it's just going to be butyl for our rubber outside, and then we can select some plastic, some industrial grade plastic for the material of the hub. So if we just look up plastic, we can select a high density plastic for this. So we'll go with some polystyrene for high impact. And that's it. That's our wheel design. That's the entire of the process of designing something like this. Now we can create a shaft with a keyhole and maybe some fastening methods and start assembling it into a larger system. Hope this was a good tutorial. Please let us know if you are interested in getting more Onshape tutorials like this one. Hope to see you soon.